Good morning, this is your Stat Sensei, Mr. Sensei, and this is a warm-up on chi-squared. College stats is a scenario. To investigate whether taking high school statistics impacts college GPAs, a very large school district randomly selects 450, so we have a sample size of 450 college students out of the more than 20,000 students who are now in college. All right, so this is the population and records whether they took high school statistics or not. They also classify each student's college performance based on their GPA into three categories. At alpha equal 0.05, determine whether there is statistical evidence that taking high school statistics is associated with college performance. When I see that word associated, I'm like, oh, this is probably a chi-square test of independence. So answer the following in the question. Is this a chi-square test of independence or goodness of fit? Well, I see associated, I'm thinking it's independence. But the way I checked, how many samples are there? Well, they randomly sample a 450. And then I noticed that there's two variables. All right. So because this makes making this a chi-square test of independence, because it's one sample and two variables, it can only be a chi-square test of independence if it's one sample and two variables. All right. Now, a goodness of fit would be 1 and 1. This is a 1 and 2. While we're here, I'm going to go ahead and and say, you know what? What is what are my variables? In this case, variables, I could take stats, and that's a yes or no, so that's two levels. And my college GPA, we have high GPA, medium, and then of course low. They also wanted us to go ahead and um, calculate our expected value. So I'll go ahead and do that. So what I need to do is I need to enter all this data into the matrix. So second matrix, arrow over to edit. And in this case, we always have to pay attention to the rows and columns, but leave out the totals. So this ends up being a 2 by 3 matrix. So 2 enter, 3 enter. And we have 70, 75, 40, 75, 110, and then we have 80. And I have to leave the matrix, so blue mode. Then I'm going to run the test, stat test, chi-squared test, calculate. I get a bunch of information, but I don't have my expected values. To do that, I'm going to have to go blue matrix, arrow to edit, and drop down to letter B. There I have them, 59.61. And then 85.389 and 76, excuse me, 76.056, and then 108.94, and then 49.333, and 70.667. All right. The next one, preferred pets. A college student organization is conducting a study to determine whether students at their university have an equal preference for different types of pet. The university is considering pet-friendly housing and needs to know what kinds of pets students are most likely to own to help shape housing policies. A random sample of 500 students, all right, so we know our sample size is 500, from a population of at least 6,000. All right, so we know our population size. Is surveyed, and each student is asked what type of pet they own. If preferences were evenly distributed, each category would have 100 students. Well, that's nice. Use alpha 0.05 to determine whether college students equally prefer different types of pets. Is this a chi-square test of independence or goodness of fit? Well, to know that, I need to know how many samples there are and how many variables are. Well, in this case, I have one sample of 500, all right? And I have one variable, one sample, one variable. This can only be a chi-square against a fit. Chi-square against a fit because there's only one sample and only one variable. If this had been two, it would have been a test of independence. But since it's only one, it's a good as a fit. The other thing it says, give the expected values. So what I need to do is I need to go to stat edit and 120, 140, 80, 90, and 70. Now that told us the expected values, but I'm just going to fill this up with ones. Now, how many categories are there? One, two, three, four, five. So I'm going to divide all these by five. Blue, two, divide by five. And I get 20%. I'm going to go back up and now I'm going to multiply, excuse me, blue 2 times my sample size because expected value is always NP. So blue 2 times, in this case, 500. And we're going to get the 100 that they already mentioned right here, which normally that won't happen. All right. I appreciate you watching. Look forward to seeing you on the next one. Thank you.